Hello everyone. This is our second lecture for estimation. Here we will focus on how to construct a confidence interval. Confidence interval estimates for the population mean are calculated as the point estimate plus or minus a margin of error. The margin of error is the expected difference that we think is possible between our sample statistic and the population parameter. Not to be confused with sampling error, which is the gap or the difference between the actual gap or the actual difference between a sample statistic and a population parameter. The margin of error of a confidence interval estimate of a parameter depends on three factors. 1. Level of confidence. As the level of confidence increases, the margin of error also increases, and vice versa. 2. The sample size. As the size of the random sample increases, the margin of error decreases. This is a consequence of the law of large numbers, which states that as the sample size increases, the difference between the statistic and the parameter decreases. And 3, standard deviation of the population. The more spread there is in the population, or as standard deviation increases, margin of error increases. Now the question is, how do we construct a confidence interval? The formula to construct a confidence interval is as follows. Sample mean plus or minus z critical times sigma divided by the square root of n, or sample mean plus or minus a margin of error. The confidence interval, so Ci, is equal to the sample mean plus or minus z critical times sigma over the square root of n. So we can say 95% of all sample means that will result in confidence interval estimates that contain the population mean would be written as 95% confidence interval, the mean plus or minus, or sample mean plus or minus 1.96, which is our z critical value for 95% confidence level. So the sample mean plus or minus 1.96 times sigma divided by the square root of n. If population standard deviation is known, we use z critical value and sigma to calculate standard error. If population standard deviation is unknown, and if n is greater than or equal to 30, we use z critical value and s, or sample standard deviation, as an estimate for sigma to calculate the standard error. Remember, S, or sample standard deviation, is S is our sample standard deviation. If n is less than 30, then we use a t critical value and S as an estimate for sigma to calculate standard error. Interpretation, here's an example. A 90% confidence interval indicates that if we obtained many simple random samples of size n from the population whose mean mu is unknown, then approximately 90% of the intervals will contain mu, or population mean mu. So for example, if we constructed a 90% confidence interval with values between 12 and 18, we would interpret the interval as we are 90% confident that the population mean mu is between 12 and 18. Be sure that you understand that the level of confidence refers to the confidence in the method, not the specific interval. So, a 90% confidence interval tells us that the method will result in an interval that contains the population mean mu 90% of the time. It does not tell us that there is a 90% probability that population mu lies between 12 and 18. So to summarize, confidence intervals are a type of inferential statistic that calculates an interval estimate for an unknown population parameter. The larger the sample size n, the margin of error decreases, which leads to a more narrow confidence interval, and vice versa. The higher the confidence level, the margin of error increases, which leads to a wider confidence interval, and vice versa. The higher the standard deviation, the margin of error increases, which leads to a wider confidence interval, and vice versa.